The shock absorber is one of the fundamental elements of the vehicle suspension system. Its function is to stop spring oscillations, providing control, grip, stability and comfort to the occupants of the vehicle. This rebound valve comprises three types of basic elements that control oil flow. Flexible discs with the bleed perforations required to control force at low piston speed, 0.12 meters per second. The set of flexible discs necessary to control force at medium speed, 0.42 meters per second. And a perforated central cylinder or interface which manages the force when the rod moves at high speed, 0.76 meters per second. In twin-tube shock absorbers, we also find a compression valve at the base of the working chamber tube. The configuration of this valve is similar to the piston valve, but inverted. It is also smaller in size because its design takes into account the damping force provided by the coil springs during compression and other elastic elements of the suspension system. Compresses due to uneven ground, the rod enters the working chamber, increasing the pressure of the oil contained internally. During this so-called compression phase, the compression valve controls the resistance of the damper movement, while oil flows almost freely from the bottom of the working chamber to the top through the piston valve. Increased oil pressure in the working chamber causes the compression valve to progressively open, and the excess oil to flow into the reserve tube in a controlled manner. During the rebound movement, the piston rod leaves the working chamber in a controlled manner due to the effect of the rebound valve. This movement creates a vacuum, which causes oil suction from the reserve chamber, which is equivalent to the volume of the piston rod having left the working chamber during the rebound movement. Thanks to this effect, the working chamber is constantly full of oil. The key advantage obtained by adding pressurized gas to the twin-tube shock absorber is that it avoids the phenomenon known as hydraulic fluid aeration or foaming, which appears when air bubbles form in the oil due to excessive pressure changes occurring when the oil flows through the piston valve as it moves up and down at high speed. Aeration causes noise and inconsistent shock absorber performance due to the air flowing through the valves.